You guys have been asking for it, and the day has finally come to do a complete 1-ton axle swap on this channel. This video is sponsored by Barnes 4-Wheel Drive. All the suspension components you see in today's video is from Barnes, and they're one of the few suspension companies that literally has everything you need. From joints, brackets, trusses, even DOM tubing and bolts. Shop around and you will see that Barnes has the lowest prices on the internet, and if you use our coupon code DIRTLIFESTYLE at checkout, you will save an additional 10% off. I'm gonna move along kind of fast in the series, but at the same time, I'm gonna try to deliver as much information about what I'm doing while I'm doing it. I wanna keep it entertaining, while balancing that out with making sure that I answer all your guys' questions as I move along. At the end of this series, we're gonna go to something called Trail to SEMA. If you're familiar with it, you know that it is just a thrasher. It is awesome. It's a lot of fun. I'm not even taking a truck and trailer this year. We're gonna drive this to all the trails on Trail to SEMA, hit all of the trails, push it to its limits, and then drive it home. To me, the first step of this build is the most important, and that is making marks that we can measure against throughout this process that are going to keep the axles centered in with the chassis. We want to make sure that we're not crab walking down the road whenever this is all done, and that's really easy to do. And I've seen a ton of people build things where one side is tweaked a little bit too far one way versus the other, and they get weird death wobble and all that. We're going to avoid all of these things by making sure that everything is lined up with the chassis while we're doing the building process. The way I do that is I make marks on the floor that correlate directly with the position of the chassis, and then I can basically either measure off the chassis or off the floor whenever I'm trying to line the axles up in line. So the first thing I did was I took a measurement from one side of the frame rail to the other side. I divided that in half, and then I just made a mark on like a cross member or whatever was nearby. Then I took a dot laser, and what the dot laser does is it casts a level dot above it, and it does the same thing below it. And so we can line the top dot with that mark that we know is perfectly center, and then we can measure, we can see the bottom dot, and we'll just mark that on the floor. So now I have an X on the floor at the front of this chassis, an X on the floor at the rear of the chassis, and those are both like perfectly center with the vehicle. The next step that I want to do is take a chalk line. We're going to run this nose to tail. We're going to snap a chalk line, and now we have a nice bright line from the very front of the vehicle to the very end of the vehicle that correlates perfectly with the center line of the chassis. Now that we have a center line marked on the floor, we can locate our axles. I think I'm going to stretch the front about 1.25 inches to 1.5 inches over stock. It just depends on the best way to center these new 37-inch tires in the wheel wells, and I think the rear is going to be really close to the same. I'm going to mark basically some generic marks on the floor that I know are squared up really well based on points that I choose on the frame, but if I need to make a small adjustment because I'm too close to the body with the tires one way or another, I can just make that 1/4 inch or 1/2 inch change represented on the floor whenever I need to. Before we continue, one recommendation: get yourself some clear spray paint, spray your lines on the floor, and it'll make sure that once it's dry, you have that extra barrier protection to keep this chalk from getting rubbed off your floor. I want to be able to reference these lines constantly throughout this process, and this will help make sure that I have lines all the way at the end of the build. So it's like $6 for this can, which is a little expensive for clear spray paint, but you can spray it inverted. To me, it's well worth the money. Anyway, I've got this axle exactly where I want it. All I did is I slid it underneath here, I got it on the jack stand, I pulled some measurements from the bottom of my tire to the center of the rim, and then I made the center of this hole the same as the center of the rim. Then I went over to the other side, made sure it was identical. Boom, we have our height figured out for our axle. I like to set everything up at right height, and so that's exactly what we're gonna do. Then I centered the axle with the chassis. I just took a line laser, I ran it down the line that we snapped onto the floor earlier, and then I used that line in conjunction with the center mark that I made on the axle. So I measured the axle, divided it in half, put a center line on it, and now all I have to do is run it across that laser, and I know that this axle is perfectly in center with the chassis of this vehicle. Boom, that is done. Now, the most important measurement, in my opinion, of all of the measurements, and that is deciding your caster. My recommendations, and this could be controversial, who freaking knows these days, is 6 to 8 degrees of caster to combat death wobble on a lifted vehicle. I think that this is a really sound number. If you want to go off some factory specs for your Nissan or your Toyota or whatever, by all means do it. But to me, this is a really good zone to stay in to combat death wobble and to keep everything nice and straight going down the street. So that is what I did here. I used this little level. I put it right there on the inner C, and we're at I think we're like 6.1. We're perfect. We're exactly where I wanted it, based on the planning I did when I built this front axle. Also, if you're not familiar with the channel, this is a driver's side Super Duty, so driver's side drop Super Duty axle that I turned into a passenger side drop. And I talk a lot about caster and stuff like that in that video. So I'll put a link in the description if you guys want to go back and check that out. But now the axle is where I need it. I mean, I centered it in the wheel well where I think would work the best. It's stretched out about as far as I want to stretch it. And it's centered, it's at the right caster. This thing is ready to tack on the suspension, and now we're ready to talk about what suspension system I'm using. I hope you're still with me. I'm tired of hearing me talk too, but there is one more subject we need to cover before we get to my favorite part, which is the building. And what we need to cover is suspension geometry, at least the basics. This is a topic I get asked about from you guys constantly, so I just want to take a minute, talk about it really quickly, and then we're going to get to work. So this is my recommendations for the orientation of a 3 or 4 link on the road, and this is my recommendations for off-road. This is how we're going to build the Discovery. This is how I built my TJ. If you've got a JK that's a weekend warrior type of deal, so you drive it all on the street all week and then you go off-road on the weekends, this would be what I recommend. If you've got a Toyota and you're wanting to convert it from leaf springs to a 4-link, this is what I recommend. If you look closely, the biggest difference between the two is this upper link and the length of it. If you set it up to where your upper link is level and your lower link has like a 5 to 10 degree tilt, all of these rules will apply to you. If you get crazy and you start doing some really weird things with your upper and lower link and angle, then some of these rules will change, but 99% of you are gonna be doing it like this. So the reason that I recommend this being the on-road orientation has everything to do with the way the caster changes throughout the suspension travel. I don't see this talked about nearly enough. If you're going 70 miles an hour down the freeway, let's say you're on a mountain pass or something like that, you get into one of those crazy 4-inch deep potholes. When the differential goes down and back up, you want it to stay in the orientation that you set it up at ride height, because this is going to give you the best resistance against death wobble and undesirable handling characteristics at speed. If you set it up like this, when you hit that pothole, the differential is going to pivot in and out of that pothole, and you're going to feel that in the wheel. This can trigger death wobble. This can also, you can build this in a way to where it won't trigger death wobble, but you're going to need really long links in order to do that, and there's just a few other things that we would need to cover in order to get into that. I think the basic way to set it up for on-road application is just like this for your front suspension. Now, the downside of having it set up like this is that if you're rock crawling and you drop the suspension all the way out, your drive line is going to be binding right here. It might not necessarily be binding, but it's going to be putting excessive force, excessive side load on your U-joint, and eventually that's going to wear it out. At least it's going to wear it out faster than this. U-joints are made to do this to a certain degree, but you're definitely going to see, you're going to go through U-joints a lot faster than you would in this orientation. So with my TJ, I have it set up like this. I've never had to replace a front U-joint, and it works great in the rocks. Whenever it flexes all the way out, it pivots, it points up at that transfer case, and there's not a harsh angle on that U-joint. So there's pros and cons to everything in the way that you set it up. You could do this for an on-road application. Just know you're not going to get the absolute best driving experience like you would like this, and vice versa. So however you decide to build it, just keep these things in mind. One other thing would be if you have an old CJ or something like that and you don't have a CV drive shaft where it goes into the transfer case, on-road, off-road, it doesn't matter. You want to stick to this orientation because you want to, if you just have a single U-joint here, single U-joint there, you want to keep them at like the same angle throughout the suspension travel. So that would be one caveat to this whole plan. There's so much to suspension and it's so hard to cover, which is why I haven't done a video on it, because there is a lot of information out there. If you're just getting into this world and you're a little bit intimidated, I understand why, and that's good. That means you're cautious. You don't want to build something that's just death wobbling everywhere. It's a waste of money. So I would recommend understanding this concept. This is going to be the big concept of this video. In the next video, I'll go back to the whiteboard. We'll talk about another suspension concept, and I'm just going to do this throughout the series to help you guys understand some of this terminology and some of these different things. If you want to learn more about suspension geometry and you already kind of understand this part, I would go and I'd Google instant center suspension. I would Google anti-squat and anti-dive suspension, because those three terms will help you really understand how your suspension is acting throughout its travel and the best way to maximize what you're building. Let's take a look at our front 3-link progress. I've got every mount tacked into place. I have all of my enduro joints. These are the enduro joints from Barnes 4-wheel drive. They're all just kind of bolted in there, and we're ready to make some measurements and cut for our tubing. Before we do that, I want to take my line laser and I'm going to confirm that nothing has shifted throughout this process. Make sure everything is recentered exactly where I want it. And then whenever I'm pulling these measurements, they're gonna be super accurate. What's really cool about building stuff like this these days is look at the size of the shank on these enduro joints. I have so much room for a little bit of a mess up here or there. I mean, there is a lot of room for compensation between the amount of thread on this joint plus the other side. I mean, we have a ton of adjustment here. So that's a really nice saving grace for something like this, but I still want to fabricate it as accurately as possible, so there is very little adjustment that needs to be made in the future. Now, if you were watching the little sequence that I put together before now, you saw that I built an extra beefy plate over here for the frame side upper control arm mount. The reason I did this frame isn't super thick. There are a lot of frames about this thickness. I'd say it's like an 1/8 inch or so thick, and I don't want to risk ripping this upper control arm mount off. So that's 1/4 inch plate, and I'm going to be welding in those holes all the way around, all the way around. I'm going to weld the bottom of that plate, and it's going to spread the load of this bracket over like a foot instead of like 4.5 inches. So it's going to be way, way stronger. And because I have only one upper control arm link, I can't risk ripping that off of the frame. I mean, you want to talk about catastrophe. So to play it safe, I went ahead and went the extra mile. The tubing we're going to be using is from Barnes 4-wheel drive. The lower links are going to be a really heavy duty 1/4 inch wall, 2 inch in diameter tube. And then the upper link, the third control arm, is going to be this guy right here, 1 3/4 inch. The reason you use such heavy duty tubing on the lower links is because you bang them into stuff, and if you dent tube, it loses its strength substantially, so you can't risk having a dent. Upper control arms are always made out of thinner material because they don't have a risk of getting dented because they're so high. They just don't have anything that can reach up there and get them. So an 1 3/4 inch, this is probably 1/8 wall. This is more than strong enough for an upper control arm. Even though we're doing a 3-link, this is still super strong because it's not going to get dented. And then this piece of tube right here is going to be for our panhard bar. If you've never cut links before, it's about as easy as it gets. You put your axle where you want it, you measure the distance between your joints, you cut your material, you weld it to the bungs, you thread everything back together, and then you bolt it back onto your project. links are all hooked up. I dropped the axle down quite a bit so you could see it, because the links are stuffed up in there really tighty whenever it's at ride height. But you can see, this is a very simple setup. It all is like we were drawing over there. It's just down a little bit in its travel. The next key component to make this suspension functional is gonna be our panhard bar. Before we get there, you disco guys, I've been getting questions about this. So check it out. This is the factory control arm mount for the disco suspension. I got a 5/8 end, and the bolt, the M18 bolt, fits right into the 5/8 end perfectly. So for those of you that own discos and you're wanting to learn how to do something like this on a disco, the disco is super easy. I mean, I just had to add one mount on the inside of the frame, and I was able to do this suspension system, so that's great. And what's even cooler is that this mount that's right here, factory on the disco, this is for a panhard bar, and I'm gonna be able to use this, so I just need to build a panhard bar mount on the axle. So this is turning out to be pretty easy in a lot of aspects. The other thing I want to talk about is we're going to be doing steering and panhard bar all in one shot, because the relationship is very important. I want to make sure that whenever I build this mount in the next episode and we hook up our steering, we're just going to do it all in one shot. I'm going to talk about how you need it to be lined up in order to combat death wobble and things like that. So look forward to that in the next episode. It is so hot in here. I'm going to go inside and cool off. But before I do, I want to clarify one more thing that I was thinking about while I was under there working, and that is the link separation. This is something I didn't talk about earlier, but I think it is important to mention, and that would be the separation between the upper and lower part of the axle and the upper and lower part of the frame. So this is for your mounts. You want 25% of your tire size on the axle side minimum. That's what kind of the rule of thumb is. So if you have a 40-inch tall tire, you want this separation to be 10 inches between your upper and lower link. The closer you get them, the more twisting force is going to be able to be applied, and the more leverage the axle is going to have on your brackets. And this will change some small handling characteristics, but the biggest one is that it's going to be able to rip off brackets. You don't want to do that. On the frame side, it seems like a lot of people say 4 inches. I haven't really seen a rule of thumb for the frame side. I've seen some people put them, right next to each other. It just changes, it changes some things. It changes your instant center for sure. So this is something else to keep in mind whenever you're building your first one. Again, do tons of research, but if you decide to use this to help supplement some of that research for now, so you can kind of get your head in the game, I think that it's a good place to start. I really do. If you enjoyed the video, give it a thumbs up, subscribe to the channel if you haven't already. This is a whole series. I'm going to be doing a bunch of one-ton swap stuff. I'm really excited to dig into this. I know that a lot of my Land Rover friends are loving this because there's like no Land Rover specific channels, but these are all techniques that you can do to any vehicle. So I hope you guys enjoy it. If you want to help support the channel, you can go to thedirtlifestyle.com. We have t-shirts, hats, neck gaiters. We got a bunch of new stickers. We have patches, all kinds of stuff. We also have a link to our Patreon account if you want to help contribute in that way. If you want to follow me on social media, I'm @DirtLifestyleNate. We'll see you next time.